Hello, our video today is going to cover Chapter 1 of Introductory Chemistry. Chapter 1 is titled The Chemical World, so this is going to be a basic introduction to some of our topics. For the most part, the way that we learn chemistry is that we start with a very broad topic, and then each chapter we get a little bit more specific. Nearly everything that surrounds you is a chemical. It's made of chemicals. And chemicals are made up of very small pieces that we call atoms or molecules. And we're going to define those later on a little bit further. We just need to know that those are some very small building blocks. And what those atoms and molecules look like determine information about the properties. So the couple of molecule models that are down here, and I use the word model because it's a way to represent what the molecule looks like. But on the left, we have CO2. CO2, or carbon dioxide, is made up of one carbon atom in the center, and then two oxygen atoms, one on each side. And then the molecule on the right is water, H2O. So we have an oxygen atom in the center and then a hydrogen atom on each side. So notice that these are each made up of 3 atoms to create one molecule. There's a difference in atom types and in the ratios. So in the first one, there's a 2-to-1 ratio of oxygen to carbon. And in the second one, there's a 1-to-2 ratio of oxygen to hydrogen. There's also a difference in their shapes. So carbon dioxide is just straight across. It almost looks like a little ant, like we should put some little legs and antennas on it. There's my little ant. And the water molecule has what we call a bent shape because it's at that little angled, a bent angle. Both of these things help determine the behaviors and properties. At room temperature, carbon dioxide is a gas and water is a liquid, and both of those things can be explained by their atom types, their shapes, the way that they're bonded together. What is chemistry? So it is something that we do need to define, and it has a pretty broad definition. Chemistry is a connection between the microscopic world that we can't see and the macroscopic world that we can see. So another way to say that is that we try to understand the world around us through an explanation based off of the atoms and the molecules. So the chair that you're sitting in or the bed that you're sitting on has some give to it. It's a little bit squishy. But the table that your laptop is on is hard. Both of those properties are determined by the molecules and the atoms that created those products. Chemical is not a dirty word. So I take a big sigh on this slide. One of the goals that I have for this class is to make you all a little bit more chemical literate, meaning just more knowledgeable about chemistry in the real world. And one of the things I hate seeing are phrases like, if you can't pronounce it, you shouldn't eat it, or chemical free. Nothing is chemical free. Everything is a chemical. And if you can't pronounce it, you shouldn't eat it is such a dumb thing to say. It just means you don't know what it is. So the example I have on here is the ingredients of a kiwi. Their chemical names. Now these are things that people might be scared of out of ignorance. That doesn't mean that they're bad for you. We know that kiwis are good. They're a fruit. It contains all of these chemicals. So something to take a step back from when you hear that it is not a bad thing. You are made of chemicals. Everything you're touching and eating and drinking is a chemical. Okay, I'll get off my soapbox now. The biggest topic in this chapter is the scientific method. Now, if you've taken another science class, anything from physics to biology to psychology, sociology, you've probably learned about the scientific method. The scientific method is a way for us to understand and explain nature by conducting experiments and making observations about them. There are 5 main parts to the scientific method. So they're down here. We have observation, hypothesis, experimentation, laws, and theories. So we're going to go through each of those parts. And we're going to start with observation. And we're starting here for a very good reason, because this is where if you were conducting experiments and figuring out laws and theories, this is where you would start. An observation is a way to gain information about something, which I know is a very general way to say that, but it can be a very broad range of information. Some observations we can get just by literally observing the object. And this is what we call a qualitative observation. So, sorry, I went too far there. There we go, qualitative observation. And so this has to do with some type of quality. The opposite to this, which we'll look at an example of, but the opposite is quantitative. And so quantitative has to do with numbers. And then that means qualitative is anything that's not number-based. So I like to think of it as qualities just because it kind of matches the word, but it also makes sense. So the examples that are on here are based off of soda. And so a qualitative observation could be that the soda is brown, it's a liquid, it is sweet, it has bubbles in it. Those are all observations. They're not explaining anything. They're not telling us why. They're not making a general, wide sweeping observation about all soda in the world. It's about this one specific soda. The quantitative observations usually require some type of instrumentation to do some measurements. So the quantitative observations here are that a 240 milliliter can of soda contains 27 grams of sugar. Now this is something that we can gain from the nutritional facts on the can or the bottle, but it is something that somebody had to measure along the way. So these are our 2 types of observations. Now in chemistry, most of our observations are quantitative, and we use qualitative ones to help us. In other fields, psychology, the majority of the observations would be qualitative, especially if we're looking at human behavior. So these are both valid, they're both used, it just depends on what we're looking at and what we want to learn. A hypothesis is a way to explain the observations. Now, there's a couple important words on this slide. One is tentative. Now, the reason why that's an important word on here is because when a hypothesis is made, it doesn't have to be the final step, and it's not the final step. So we say it's tentative because that means it can be changed. It can be completely thrown out if it needs to be, but it's tentative to allow us room for improvement. It is falsifiable. Falsifiable, another way to say that is that it is testable, meaning we could do an experiment to see if this hypothesis is true or not. So this is the reason why religion doesn't fall into a category of science. It can't be proven true or not true. Anything within the supernatural realm can't fall into this category because it's not testable. The observations on the previous slide gives us this hypothesis here, it says the sweet taste of soda pop is due to the presence of sugar. So our observation was that it's sweet, and the reasoning, the hypothesis, is that it has sugar in it. Now, because our hypothesis is tentative, we have to have a way to figure out how accurate it is. And so that leads us to the third step, which is an experiment. An experiment will test a hypothesis, a law, or a theory. And we can either confirm or deny a hypothesis, law, or theory. Another way to say that is that we can support a hypothesis, law, or theory. And if it is supported, that is great. And if it is not supported, or if it denies it, then that means that we can change our hypothesis, theory, or law. We can modify it and retest it. So there's a cyclic nature. And at the end, I'll show you a graph that kind of combines all of these pieces together. Now, the last sentence here, it says, just because our hypothesis has been validated or supported doesn't mean that it will always hold true. This has been particularly true in science because as these old hypotheses and laws have traveled with us, our technology has gotten better. And so we've had to modify some of the hypotheses and laws that have been around for many, many years because we have better instrumentation to check them or validate them. The next category is laws. And a law is a summary of observations that combines all past observations into one general statement. So our first observation was that the soda was brown and sweet. Well, that doesn't include all soda. We could make a more general statement about all colas or all colorless sodas like Sprites and 7-Ups, but it would combine all observations into one sentence. The example that's on here, which is one of the laws you need to know, the law of conservation of mass, says that in a chemical reaction, matter is neither created nor destroyed. So this means that when a chemical reaction happens, however much mass we start with is the same amount of mass that we end with. This was figured out by burning things, weighing them before and after they were burned. So the example on the bottom there is if you have a log and you burn it in fire, together it weighed 31 kilograms. After it's burnt, it's still going to weigh 31 kilograms. Now this takes into account the ashes that are left behind, but also the smoke. So the smoke would have to be contained within a vessel so that it could also be weighed. We can't magically make new material, and we can't magically lose material. It all has to stay the same. And then our last category within scientific method are theories. A theory is a general explanation for the characteristics and behavior of nature. So really, a theory is a very well tested and validated hypothesis. And the big one on here is Dalton's atomic theory. So that's a picture of John Dalton over there. John Dalton's atomic theory is a way to explain a lot of information about nature. He said that atoms are small, indestructible particles, and this has been used to explain a lot of the behaviors of atoms and molecules throughout the years. One important piece about a theory is that it can be used to predict future behavior. So if we know why something is happening, then we can predict what will happen in the future. So I'm going to show you an example of using the scientific method. And this was something that I did in quarantine this year. So this is my cat, Penny Lane. The observation is that she really likes to sit in boxes. And my hypothesis is that she would love to have a castle made out of boxes. And I did a lot of online shopping, so I had a lot of extra boxes laying around. So here's my experiment. I built a cardboard castle, and I observed what would happen. Also, right here, that's my sister. She's also a teacher. She teaches elementary school. So that is the flat version of her that she sent to all of her students and to me, so I could take pictures of her doing things. My observation, she didn't like the castle. I gave her some treats in there. She went and got the treats, but then she was done with it. So my revised hypothesis, based off of my observations, is that Penny Lane would like a cardboard castle with large doors and lots of windows. So, Castle 2.0. I made the doors bigger, I added more windows, and I made the tunnel an arched walkway. Yes, I had lots of time on my hands. The new observation is that she loves her cardboard castle now, and the hypothesis is supported. We use the scientific method all the time without really realizing it. I didn't go into my cardboard castle quarantine activity thinking about the scientific method, but I was using that process. We know that as we're doing things, we look for what's happening. If you're cooking and you taste something, you're seeing how it tastes, and your observation, if it needs more salt or garlic or paprika, you add that based off of the observation you made, that it didn't taste quite right. So we do these all the time without really realizing it. Now, the hypothesis, theory, and law can be a little bit confusing to make sure that we know the difference. So we're going to start between the difference of a hypothesis and a theory. They're very similar. The biggest difference, though, is the amount of observation that was used to create them. So a hypothesis is an explanation of a single or small number of observations. My cat likes boxes. Therefore, she'll like a cardboard castle made out of boxes. That was based off of one cat and my observations of her sitting in boxes. A theory is an explanation that extends beyond just my cat and goes on a more broad scale. So this is going to look at the way nature is or behaves. So not just my cat, but all cats. The difference between a law and a theory. A law answers what will happen. So it is a way to predict future events based off of past events, but it's not telling us why it will happen. So a law could state that if you put a box out, a cat will sit in it. A theory is going to tell us why that observation is happening. A cat will sit in a box because it's going back to its instincts of sleeping in a den. It's telling us what will happen. The cat will sit in the box, but it's also telling us why it's going to happen. So it's giving us a little bit more information. And this is our final slide. This is giving us all of the connections between those 5 pieces. So we're going to start over here with our observation, which can lead us to a hypothesis if we're just talking about a small number of observations, or it could lead us straight to a law if we're talking about a large, broad observation. And then once we have our hypothesis or law, we're going to test it using our experimentation, and then whether it validates or invalidates it, we can revise it if needed. That hypothesis can then turn into a theory once we've tested it many times and we have a lot of data to back it up. Again, that theory, though, can continue to be experimented with and revised as necessary, especially as time passes and technology gets better. So that is it for Chapter 1. Thank you.